Welcome back and thanks for joining me in this second part of these 3 short videos on cognitive load theory. Thanks to all those people who asked questions in the interim, and we'll get a chance for me to address a couple of them today. The goal of these 3 videos is to give you a bit of an insight into cognitive load theory and a bit of a shortcut to some of the key understandings that are hopefully going to help you to transform your teaching. In the first installment, I talked about how Dylan Williams' tweet sent me down a bit of a rabbit hole from which I still haven't emerged, exploring cognitive load theory through the books and eventually getting on a plane and going and actually meeting John and cultivating a relationship where John has consistently helped me to gain a better understanding of CLT. Last time we covered a few key ideas of cognitive load theory. First, we heard about the idea that cognitive load theory is a set of instructional recommendations built on the cognitive architecture of human memory. And this image really captures that, and we learned that working memory, with its limited elements, is the bottleneck of thinking. We then looked at element interactivity and how it's valuable for us to cultivate a sense of the number of elements that we're asking our students to contend with at any given time. We then looked at 2 practical strategies for teaching in line with these ideas. The first was the idea of simplifying conditions. So whether you're doing a presentation, painting, science, or teacher training, or anything else really, it's really valuable for us to be aware of the number of elements that we're asking our students to deal with and learn at any given time. And the final idea we looked at was the idea of pre-teaching with scaffolds and how that can help to reduce the number of elements that students have to deal with. Hopefully that video helped you to get a better sense of the essence of cognitive load theory. This time we're going to look at some new content, and we're going to start with addressing 2 questions from viewers from last time. The first is about categories of cognitive load, and the second is about the transition from information from short-term memory or working memory to that long-term memory. And then we're going to look at the idea of the split attention effect. So let's jump straight in. The first question was from Ian, and this is how Ian put it. Okay, so some big words here: intrinsic, extraneous, and germane cognitive load. So let's dive in and see what we can find out. In simple and non-academic terms, intrinsic load is as follows. Intrinsic load comes from the core to-be-learned information, and we can modify intrinsic load by looking at curriculum sequencing and changing background knowledge. So that's the idea of intrinsic load. Anything that we want students to learn or that's crucial for them to learn is and can be considered as intrinsic. The next idea is the idea of extraneous cognitive load. Now, extraneous cognitive load basically comes from anything that is extraneous to the learning task. So anything that we don't really need our students to learn can be thought of as extraneous cognitive load. What this means is that extraneous load comes from the manner and structure of our instruction. And extraneous cognitive load is actually the target of most, if not pretty much all, of the cognitive load strategies. They're all trying to reduce extraneous cognitive load. So one way to visualize this is if we think about working memory as a finite box. So this is the working memory capacity that we have. And when we ask our students to learn something, that box is going to be filled up with a combination of intrinsic load and extraneous load. And this is what it can look like. So we've got a box which represents the finite capacity of working memory, and that's partially filled of intrinsic load and extraneous load. And this student also has some excess cognitive capacity that could be allocated to further learning. So this actually brings us to the key recommendation of cognitive load theory, or the fundamental recommendation, and that is, in order to increase learning, we must reduce extraneous load and optimize intrinsic load. So Ian, you asked for a practical strategy, and this is basically what we're trying to do whenever we try to use cognitive load theory to optimize instruction. Reduce the number of distractions, which we can kind of think of as extraneous load. They're either distractions from other students or maybe from the way that we're presenting the instruction, and optimize the intrinsic load. So if students have space in their working memory for more learning, we should fill it with the good stuff. Now, there's also this other idea floating around, which is this idea of germane cognitive load. And I've just clipped out an excerpt from the paper Cognitive Load Theory and Instructional Design, 20 Years On, and I'll just give you a second to read this now. Now, it was asked that this was communicated in non-academic terms, so let me translate this. For all intents and purposes, it's not that helpful of a construct at this particular point in time in terms of understanding how students learn. It's a little bit intertwined in intrinsic cognitive load, and going into detail to explain it isn't actually going to help us much. And to give you an example of this, I actually wrote a summary of these ideas, the different types of cognitive load, and shared it with John Sweller recently, and I didn't include germane cognitive load. And I said to John, do you think this is an omission that's actually going to get in the way of teachers learning and effectively using this in the classroom? And John basically said, no, that's not a problem at all. Intrinsic and extraneous, if teachers can get their heads around those two concepts, then that's totally fine. So what that means is that this concept of germane cognitive load is actually itself extraneous, and we don't need to worry ourselves too much about it. So hopefully that's a clear enough summary of those key categories of cognitive load. So the next question was from Heather, and I'll just give you a second to read this one as well. So there's a few things that I wanted to say in response to this one, and I'd like to start with a bit of a broad description about what it actually means to learn something. So whenever a student learns something, or whenever indeed we ourselves learn something, that learning is built upon the structure of human memory. And human memory has an associative structure, which means that new bits of information are integrated into our memory system through associations to old information. So whenever we understand something, we're actually just connecting it to something else we already know. And the more deeply we understand something is represented by more connections. Efrat First actually represents this really well. If you check out her website, Efrat First, she's got a lot of really good diagrams that represent the way that memory is constructed and the way that memory and understanding develops over time. Now, this idea of repetition is actually really important, because for two ideas to be connected in our brain, what's actually happening is electrical signals are being sent along various new pathways within our brain. And the more times that those electrical signals are sent along the same pathways, representing the same memory, the stronger that connection gets. So in many ways, yes, simply repeating the same information is likely to strengthen the connections that are made in order to help the student then remember those ideas. So in a basic sense, yes. I guess the caveat to that is we need to think about the way that the new information is getting connected to the old information. The more secure and robust that connection can be made in the first place, and by secure and robust, I mean it's easier to make a connection if the connection is a shorter distance. So the more closely we can relate a new concept to something that our students already know, the less effort and the less time it's going to take for that connection to become a strong and robust one. So if we're trying to teach students some word that's completely foreign to them, then that's going to be so far away from any of the knowledge system that you already have that it's going to take so many repetitions to embed that. But if I can somehow formulate that knowledge in a way that relates closely to something you already know, then it's going to be a lot easier to remember. So two key ideas in response to your question, Heather. The first idea is that yes, repetition in and of itself will be useful, but also keep in mind the closer the new information is, or the more we can relate the new information to something the students already know, the less repetition will actually be required. And now I want to share with you one strategy, cognitive load strategy, which is in relation to the split attention effect. So remember before, I said that the key idea of cognitive load theory is to reduce extraneous load and optimize intrinsic load. And the split attention effect is all about reducing extraneous load. Let's jump in. This is the little rhyme that I've used to summarize the split attention effect. Information that must be combined should be placed together in space and time. So there that one is again. There's some repetition for you. So as an example of this, I was in a classroom not that long ago, and it was in a lesson of, it was either a year 7 or a year 8 science class, and the teacher was teaching the students about the periodic table. There was a slide on the board that looked a little bit like this. It talked about the different parts of the periodic table, and each student had their own periodic table, and the teacher was guiding them through it very clearly. So the teacher would say something like, each box on the periodic table represents an element. Okay, I want you to choose an element on your periodic table and point to it. And the students would point to it. Then the teacher would say, the atomic number gives the number of protons in the element. And so she would say, oh, that atomic number is up at the top left. So look at the top left and put your finger on that, and that's that number of protons. What's actually happening here, even though the teacher's instruction was very clear, what the teacher was actually asking the students to do was to split their attention between two places. One was the board, and one was the periodic table in front of them. And this brings us back to this idea of element interactivity. So there were two elements, but the interaction between those elements was quite disparate, was quite far apart. And when we introduce more complex interactions and split that information, that actually induces more cognitive load on the students. So anytime that we ask students to integrate two bits of information which must be combined in order for them to understand it, the closer we can put those bits of information in space and in time, the less burden that will place on students' working memories. So after the lesson, I had a bit of a chat with the teacher. I spoke briefly about this idea of split attention, or splitting students' attention between two places, and we came up with the following slide, which was designed to be an improvement upon the first iteration. So you can see what we've done here. We've actually brought up the element here, and we've actually physically integrated or pictorially integrated it with the ideas. And so what this means is that instead of the student's attention being split between the board and the periodic table, we've integrated it and we've reduced the amount of cognitive load that stems from their need to integrate the two bits of information. So this is one example of the split attention effect. I'll show you another one. Often we generate split attention through our writing, and I've got two writing examples here for you to consider. Here's the first one. That's the first example, and here's the second. Almost exactly the same words, but a slight rearrangement. And if I were to ask you which of these two examples is clearer, I would expect that your answer would be the second. Let's look at the difference. In the first one, we said there are three key resources that we all draw upon: environment, working memory, and long-term memory. We then said the first is blah, 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 the second is blah, 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 and the third is blah, blah. What's actually happening here is we've introduced these three elements: the environment, working memory, and long-term memory. And then we've asked the reader to hold those three elements in mind in their working memory while they process the next bit of information. So when we say the first, we're actually asking the reader to remember the idea that the first element was the environment. When we say the second, we're also asking them to remember that the second element is working memory. Again, this is splitting their attention and causing extraneous cognitive load. If we look at the second example, there were three key resources. We introduce them, but then we actually repeat those ideas when we associate them with the key information. So we say the environment is an unlimited external storage of information. We haven't asked the learner to hold anything in working memory there because we've physically integrated those two ideas, and so on. And so this is another example of how the split attention effect tells us that information that must be combined should be placed together in space and time. I chose to share this split attention effect today out of all the other cognitive load effects that I could have talked about, because it is one of the ones that I see the most in classrooms. And so I encourage you, as you plan your lessons for the week to come, or think about how you might communicate an idea, or even when you're reading a book or maybe writing something, think about the way in which your attention is being split, or perhaps you are asking your students to split their attention, and whether there's actually a way that you could be integrating that information to reduce the number of elements that students need to hold in working memory, and therefore to make something easier for them to understand and learn. So a quick recap of what we've learned today. So the first question that we addressed was about categories of cognitive load. Remember, intrinsic cognitive load comes from the content that we want our students to learn, and we can adjust the intrinsic cognitive load by breaking apart a task. So the students still get the key ideas, but they're just spread out over time, and we'd call that curriculum sequencing. And we alter extraneous cognitive load through changing the manner and structure of instruction. And those two ideas were combined into the fundamental recommendation of cognitive load theory, which is to reduce extraneous load and optimize intrinsic load. And we also learned that germane cognitive load is not something that we need to worry about too much at this point in time. The second question was about how information moves from short to long-term memory, and we talked a little about the associative nature of human memory, how repetition does help because it helps to fire and strengthen those same neuronal pathways, but that's a bit of a brute force method, and in addition to just using repetition, it's valuable for us to think about how far away the new information is from what students already know, and try to ensure that we teach in a way that the new information isn't too far away, so it's easier for students to make those associations. And the final idea, information that must be combined should be placed together in space and time, with those two examples of the split attention effect. I will be doing one more brief video that you'll be receiving on Tuesday next week. So if you have any questions before then, please send them through and I'll endeavor to get through them, as well as give you another one or two insights from cognitive load theory in that final video. Thanks for your time today, and I hope you enjoy trying out some of these strategies in your own classroom.